We're in lesson 5 of chapter 2, which will be equations with variables on both sides. First, we're going to solve an equation with variables on both sides. Then we're going to solve a real-world problem. Then we're going to identify the number of solutions of an equation. So here's a situation where we would work with an equation with variables on both sides. Here we have two different pet shops. We have Sally's Pets, which will take care of your pet for $19 plus $1.50 for every hour. Then we have the Mom and Pop Pet Shop, which only charges you $15, but then $2.75 per hour. The question is, at how many hours will Sally's Pets be the same price as the Mom and Pop Pet Shop? So to solve something like this, we can make an equation because we want them to be the same. We always have an equal sign in the middle of an equation. On the left side, we can do Sally's Pets, which would be $19 plus the $1.50 per hour, so H for hour times H. Then Mom and Pop Pet Shop, we can do $15 plus the $2.75 they charge per hour, so $2.75 times H. And you notice we have an H variable on both sides. And for this example, I'm going to subtract the $1.50 H from both sides of the equation to get rid of this. So minus 150, minus 150. This would cancel out. This becomes 125H. And then over here we can get rid of this 15 by subtracting 15. 19 minus 15 is 4. These cancel out. So we see that 4 equals 125H. We can divide by 125 then. And when we do 4 divided by 1.25, that gives us an answer of 3.2. So 3.2 now equals just H, or the number of hours. So we would say at 3.2 hours, these would be the same price. Let's try a few more of these variables with both sides. Here it tells us to solve this one. 7 minus 8x equals 4x minus 17. So like before, we want to move all the variables, or x's in this case, to one side of the equation, and all the constants to the other side. Since 4 is smaller than 8, I like to get rid of that one first. So minus 4x minus 4x. These would cancel out. Here we have minus 8x minus 4x, which equals negative 12x. Then we can subtract 7 from both sides. I have negative 17 minus 7, which equals negative 24. So negative 12x equals negative 24. I can get x by itself by dividing by negative 12. So my answer then, this would cross off, giving me just x. Negative 24 divided by negative 12 equals positive 2. This next one will take a few steps. We have 9x minus 5 equals 1/4 16x plus 60. In a situation like this, we can use that distributive property to distribute the 1/4 and multiply that times both of these numbers. So over here we still have 9x minus 5 equals 1/4 times 16, which is 4. So 4x, drop that plus down. 1/4 times 60 is 15. So like before, we want to get these x's to one side of the equation and the constants to the other. So we could subtract 4x here. That would give us 5x, and cross this out. Then we could add 5 here. 15 plus 5 is 20. So that gives me 5x equals 20. I can divide by 5. And then x would equal 4. Let's try solving a real-world problem. It says the car dealership sold 78 new cars and 67 used cars this year. The number of new cars sold by the dealership has been increasing by 6 cars each year. The number of used cars sold has been decreasing by 4 cars each year. If these trends continue, in how many years will the number of new cars sold be twice the number of used cars sold? So in a situation like this, we're comparing the new cars to the used. So we could put new over here, and we can put used over here. And we're making a comparison, so we can have this equal sign in the middle. So what do we see about the new cars? Well, we see that they sold 78 this year, and it's increasing by 6 each year. So that means we have 78 plus 6 times the number of years. For the used cars, it's decreasing by 4 each year. So they start at 67, but they're losing 4 cars every year. We would be done if we wanted to find when they would equal each other, but that's not quite what we want to do. we want to see when the new cars will be twice the number of the used cars. So because we want that to be double, we're actually going to need to multiply the used cars times 2 to get these equations to balance out. So we're going to multiply the number of used cars times 2, and that will be our equation. We want to see how long it's going to take for the used cars to be half of the new cars, or the new cars to be twice of the used. So now we can actually solve this. We could distribute this 2 to both of these sides. So that still leaves us with 78 plus 6x over here, equaling 2 times 67 is 134, minus 2 times 4 is 8. We can add the 8x to both sides. That gives us 14x. We could subtract the 78 from both sides. And that gives us an answer of 56. So 14x equals 56. 14 goes into 56 4 times. So x, which stands for the number of years, equals 4. So we'll say 4 years. Now we're going to identify the number of solutions of an equation. So above here it says solve if possible. And it gives us this problem. 3x equals 3 times x plus 4. So if we do distributive property, that would leave us with 3x equaling 3x plus 3 times 4 is 12. And now just stop and think about this for a second. How could 3x equal 3x plus 12? Because 3x and 3x are going to give you the same answer no matter what number x is, and you're adding 12 to this side but not to this side. So it seems like the solution is not true. It isn't. It's an impossible solution. No matter what number we plug in for x, we cannot get it to equal 3x plus 12 because these two pretty much cancel out. If you do the math, you do minus 3x from this side, minus 3x from this side. 3 minus 3 is 0, which leaves you with 0x equals 12. 0 times x is 0. So 0 does not equal 12. So yeah, in a situation like this, you would say there are actually no solutions. And you would write that out, no solutions. How about a problem like this then? 2x plus 10 equals 2 times x plus 5. So let's distribute this 2 again. This leaves us with 2x plus 10 equaling 2 times x, so 2x plus 2 times 5, 10. Now what do you notice about this one? These are exactly the same equations, meaning that 2 times x is going to give me the same answer as 2 times x here, then plus 10 will give you the same thing as plus 10. So this means that no matter what value I plug in for x, I'm going to get the same answer here as I will here. If I do 3 for x, for example, that would be 6 plus 10, 16, equals 6 plus 10, 16. If I plugged in 5, that would become 10 plus 10, 20, 10 plus 10, 20. That means no matter what value I plug in for x, this will always be a true statement. So that means the number of solutions are infinite. No matter what value we plug in for x, it is going to be a true solution. So in a situation where you have the same variable with a different constant, that's going to be no solution. When you have the exact same variable and constant, it is an infinite solution.